Hello friends, welcome back to C4U. Today's video is about Knoevenagel reaction. We'll see reaction, its mechanism, and we'll solve some problems in this video. Yeah. So this is the spelling of Knoevenagel reaction. Some guys call it as Knoevenagel, some call it as Knoevenagel. It's just a difference of pronunciation. Doesn't matter a lot. So what is basically the reaction is? Reaction is in between a carbonyl compound without alpha hydrogen with a compound having methylene group attached to two electron withdrawing groups in presence of base gives you the product, which is nothing but alpha beta unsaturated compound. We will understand this reaction with the help of example. So here's an example with us: benzaldehyde with malic ester diethyl malonate in presence of sodium ethoxide is going to give you an alpha beta unsaturated carboxylic acid. I hope you all know the name of this compound. Very much important compound in organic chemistry. It's nothing but the cinnamic acid. Okay, so this is the same product we saw in last some reactions like protein reaction and some other ones. Okay, so how the reaction actually goes, we'll see it with mechanism. So to see the mechanism, let's go mechanism. Yeah, so what you have first CH2 with OET and OET. Basically, before going to the mechanism, you need a carbonyl compound without alpha hydrogen. What is the alpha hydrogen here then? Let's see. You have your carbonyl compound. The carbon besides your carbonyl compound is known as the alpha carbon, and the hydrogen attached to alpha carbon is known as the alpha hydrogen. So this methylene group is going to have alpha hydrogen, but see this benzaldehyde, there is no any alpha hydrogen, so you need such a kind of a compound along with this one. Okay, so basically what happens first, you have a base, and base is always looking for an acidic proton, and you have two acidic protons here though, but we are using one equivalent of a base, so it abstracts one proton and will form an enolate here. So as usual, OET, actually it's not needed to show the enolate, you can just keep it as, sorry, it is carb anion only, C11O CH minus CO OET. This is the thing. This is what your nucleophile is there. You have one electrophile which is already present in your reaction. So the reaction proceeds with this method. So it will attack here. The bond will go up. Now what you have to write is, see, you have your phenol ring which is totally untouched. Then carbon opens up here, one hydrogen is there, and now the next one is your carbon with one hydrogen, yeah, and two COTT groups, COTT and COTT. Okay, fine. Then see, your OET is abstracting the proton, so what it becomes? It becomes ETOH. And again, here comes the concept of catalyst. It enters the reaction and now it's going out. So the same molecule can go for the next ester and abstract the proton, and what you are getting is here, I'll write it in a straight manner: benzene ring with OH, CH and two COPD groups. So here we are up to this. Now the next step is of hydrolysis. I'll make it some more bigger. Sorry. I hope it's all clear now. Fine. So in next step, with acid hydrolysis, I'll write it here only. With H plus hydrolysis, as you are doing hydrolysis and you have two ester groups here, so those two ester groups are going to converted into acids. So you are getting OH, CH, CO2H and CO2H. But before this hydrolysis, there is one intramolecular reaction takes place, which makes this to go out, and here is what you have. I'll write it again. Okay, so one double bond is to be formed there. Fine. And now here what you have, CO2H and CO2H. Fine. I hope there is no confusion. First, this step comes up in this manner. Fine. So what you're having these things, and then hydrolysis takes place and you are having it. Now with the extra heat, decarboxylation occurs. It has its own mechanism, but we don't need it, and you can directly write your final product, which is nothing but your cinnamic acid. So here we are up to our product. This is what the mechanism of Knoevenagel reaction. Now we'll see one example. See, there is no compulsion for your methylene group has to be with only ester groups or acid groups or only carbonyl groups. It needs two electron withdrawing groups. So there are two nitro groups which are again electron withdrawing groups. So this is again the example of Knoevenagel reaction, and what you are getting is, we will clear it with the mechanism only. So the first thing, OET is going to abstract here, and you are getting this kind of a thing. I don't think there is need of explaining it well, because we are doing it from, I think, 11th and 12th standard. So here it goes, the bonds opens up, and you are having benzene ring with O minus, H, CH and two nitro groups. Fine. Now here, as you take that plus, you are getting OH, here is OH, here is CH and two NO2 groups. And now what happens with the elimination of H2O, you know these things, it needs some heat sometimes, but in this case the stability of your product, stability of your carbonyl, not carbonyl, stability of your double bond becomes the driving force of this reaction. Dehydration we will call it as, because this double bond is in conjugation with aromatic ring, and hence it's going to be formed. So here is both the alpha beta unsaturated compound. The carbon next to your functional group is alpha, here is beta. In the case of cinnamic acid also, see, we wrote the structure of cinnamic acid. We wrote means it is actually in practice. So you have, here is your double bond carbon OH. This is your functional group. This is alpha carbon, this is beta carbon. So alpha beta unsaturated compound is going to be formed in the Knoevenagel reaction. So this is what for today's video. In the next video, I'll come up with one more interesting and important name reaction for GET 2021, and as well